It's a lot, but today we're actually inside EIC Motorsports on the opposite side of Lakeland. And Lakeland honestly has turned into a big motorsports and drag racing capital. You have chassis builders, engine builders, everything's here. And the reason we're here is we're actually going to take advantage of some equipment my buddy Gabby has in here to do some further testing to finalize the runner design and stacks and radiuses that are inside the plenum to see if we can maximize the amount of flow that we can get out of this. So most people nowadays, you can build something that'll work, but I just want to put a little bit extra effort to just verify which design is going to work the best. And that just helps to give a much better final product. And every little bit counts in motorsports. I mean, horsepower turns into inches, turns into millimeters at this day and age. So why not utilize the tools and skills and the knowledge of somebody that specializes in airflow, cylinder head design, intake manifold design, an incredible engineer in his own, and just get his inputs where I might be lacking, but I can incorporate those readouts and those findings to help get you guys a much better product in the end. All right, so now I'm gonna take this guy off of his incredibly busy day and let him go ahead and introduce himself. This is Gabby, and he'll go from here, and we'll get.
I'm Gabby from EIC Motorsports, good friend of Tony's. We're here to evaluate some runners, some different length runners and different tapers and radiuses. He has made several different models that we're going to use now to evaluate based on a pure flow number, and we'll walk through exactly what we're going to do.
Now, a quick question. Even though this isn't like from the aspect of combustion chamber design or cylinder head port, what do you think we'll be able to gain just by comparison? Like, what have you seen since you do all of these incredible motors, these big blocks, small blocks, these all billet engines, billet heads, and all your design? It's like, what are some of the things that some people don't really pay attention to? Why simple things like this might be critical and help?
Well, a lot of people are focused purely on airflow, and a lot of it has to do. This machine is kind of like the first step. It allows you first to kind of evaluate some things and get a rough idea of an absolute airflow number. Although the engine is different where it has pulses and there's air and fuel sometimes. In this case, it's a dry manifold, but in some cases there's also air and fuel in concern. There's a lot more other factors that are involved in the actual final design, which is what we're going to encounter after this first step.
Correct.
So then this is one of the ways that we can evaluate some basic shapes and then move on to the next level as far as getting all the runners to have proper distribution and having the right orientation so that all runners are fed equally.
Correct.
So this is where we start. We'll start with you.
Everything else, plenum shape, plenum volume, all of those things we build on. But at the end, they still have to run through the runners, which is the final entry before the cylinder.
Correct. That's what ends up going into the cylinder head. So, you know, it's an extension. Basically, what you did is the extension of the cylinder head.
Correct.
The engine sees the runner as part of the cylinder head.
Correct.
It should be all seamless.
Correct. So at that point, we can see runner design will play shape. Will also affect, I would say, velocity, speed,
yes,
intake air temp, depending on like finishes on it,
absolutely,
how rough or how smooth.
Boundary layers.
Yeah.
Radiuses have a lot to do with it, with the plenum opening.
Correct. Which that's what we're doing here is mainly the radiuses, the inlets, and stuff like that.
Yep. You know, some radiuses, believe it or not, have the smaller radiuses make the runner look, for the engine, look longer than what it is, because sometimes you're adjusting some of those lengths to suit a certain RPM band.
Correct.
And then where once R&D takes place and you actually run the engines, run the manifolds or the cylinder heads in the car, then you can make other final adjustments in terms of the radiuses to try to suit the runner or to get the engine to make peak power at a certain point.
Okay.
So those are the other variables that we'll encounter after we do our basic design principles.
All right.
Yep.
So I guess let's get started from here.
both 390s. This one was like what, 40?
Yeah, that one topped out over
401,
like
402, 401, 402. Go ahead. Okay. 397. This one's a tick better than that one. Let's see this one with the big radius on it. I'd be curious to see. I wonder if it'd kill it. Whoa! This blows more. It went past the scale. Let's do it over. Let's go to the next scale, the 500.
It looks like I just need to get that one to work.
I think you need to fix the radius on this one.
And then fix the blend.
Right, fix your blending, fix this radius, make this radius better here. I don't give a shit about, you know, it. We used to do them where, you know, it was cut
I've seen
out.
them where they pretty much blend together. Because that's how the kit that I make that we weld together,
Yeah.
those things, even though they're not round, but they're a stacked and more like a oval shape,
Yeah.
they blend together, and these guys make a ton of power with that
Good.
thing.
Okay. Yeah, like
So
407.
even with a bad design,
Yeah, even with screwing it up.
okay. All right, so for everyone that's been following along on the channel, I want to thank you and appreciate everything you've done to support us. For all of those who haven't already done so, make sure to hit the follow button, subscribe to the channel, and follow us on all the socials. Make sure you stay up to date on all of the newest projects, all the details that we have coming. Appreciate it, and make sure to hit the alert button in case I forgot to tell you that. Formula for air requirements per 4 horsepower, because they have like a fuel formula.
It's sometimes, and you hear this all the time, like a really, really good engine is like between 2.2 and 2.4 CFM per cubic inch. Okay, so I think that's what it is. I don't use them. 2.2 to 2.4, which I don't. Again, I don't do a lot of that stuff. Mine is more from an area calculation and stuff. But 2.4 CFM. So then we can turn that formula around and extrapolate from horsepower potential. Yeah, so I'll have to do, let me do them.
The main findings though, no matter what the numbers are, is that we pretty much just confirmed that the runner designs, even though there were 4 variations of them, every single one of them right now can keep up with the best flowing heads that are available for these motors.
Absolutely.
The CFM numbers that these guys are putting out on these all-out heads on these race motors, this won't be a restriction, which means that's really what we're
I think it's a great starting point.
Yeah.
I think it's a great starting point.
We learned a lot and got really surprised by the one that performed the best, and now I can go actually refine this and probably pull out another 1 or 2%.
Well, yeah, once you get it all together, then we can come back and kind of refine things after you get, maybe we get all of them in one bank. We can kind of refine after you refine the radiuses like we just spoke about and a couple other things. And I think it's going to be even better than what that was.
Yep. Well, appreciate you taking the time out of your busy schedule. to help
Anytime.
me confirm and actually reaffirm some ideas and information that I got from both yourself and a couple other guys, and we're going down the right path. We're going to have a killer manifold.
I think you guys are on a very good track. The thing looks very nice.
Thank you. Appreciate it.
So it looks like we have a game plan.
Yeah, we gathered a bunch of critical information in a short amount of time just by testing. These are 4 identical runners. with their portions of the stacks, and we actually tested them bidirectionally. So we tested them on the cylinder head side as well as the plenum side, just so we could have a true evaluation of just airflow in general coming from both entries, figuring out if it was going to be a restriction either side and figuring out which one. And all of this was just based on smaller changes, but those smaller changes were significantly noticeable. And a lot of it might just be guesswork, or a lot of it, some guys might have just found out on the dyno while they were tuning, but with the help of Gabby over here and his equipment, the flow bench, we were able to see, just like you said, I'll let him go more into the details on the differences that we saw on both sides.
Well, ultimately, we fixed all the variables as far as runner length and shape and areas are all the same.
Correct.
So most of the things that we were testing here was your differences in inlet radiuses and shapes at the entry.
Correct.
So that essentially helps us kind of fix all the other variables and evaluate that, so then that we can kind of make a larger prototype with all the radiuses that we find. Right. So from our best to worst, the differences in the radiuses and the shape was roughly about 20 CFM. And what was interesting was that when we flowed them the other way, one way, as you know, some people seem to think that when you flow a runner, whether it's from one end or the other, they flow about the same. Well, we just proved that it's not. It's consistently different when you flow it, when the airflow is flowing one direction versus the other.
Correct.
But there was larger variances when we flowed it as the runner will see it, which is actually flowing through the runner out. And that was even greater than the 20 CFM number.
Correct.
So it was pretty interesting to see, and that allows you to move to the next step and use the one with the nicest radius and the nicest shape and kind of make a larger prototype with all of them, and then we can either go back to the flow bench or build yourself a prototype. Correct. That we can run in the car or on the engine dyno or whatever it is.
Correct.
Kind of move on our development.
Correct. So it's all seems to be tying in together. We're getting hardcore results in testing. We're not really just throwing anything out there, even though in this day and age, almost anything works in a forced induction environment. But I'm designing this around the parameters where you specialize a lot in, which is a lot of naturally aspirated things. Because at that point, it's horsepower turns into inches, and everybody has access to a lot of the same equipment. They're shared tuners, a lot of the shared builders. So it's like the finite things that you can have a little bit more control on. It's like that could, in my eyes, I feel that could be the issue between first and second.
Oh, absolutely.
You know, it's like you got races that are closing out that are
in the all-motor world. I mean, maybe the top 5 are within a couple hundredths of a second.
Correct.
So you're trying to find, the way we look at it is we try to find 2 or 3 horsepower in 5 different places, and that'll make you from number 5 qualifier up to number 1. Correct. You know, like that could be just a difference.
Yeah.
So you know, so every little detail counts at this point.
Yeah, and I feel it's just going to be compounded more once you add force induction. So if you don't have a really good baseline, it's like adding a bunch of boost to it. It's not really going to help you.
Well, you can crutch it, but always a naturally aspirated design typically helps the boosted applications. You know, if this is refined.
And that's pretty much the approach: is get it from the root level, refine it, and then expand it, replicate it, put it into every runner so you can equalize it, and then you know, if math holds true, we'll have something that flows very well from runner 1, 2, 3, and 4, performs, keep your IATs down, make your best amount of power throughout the entire range, and not become a restriction at a certain point in your upper power band. So appreciate it, guys. So like we said, another step in the equation, and we're moving on to the next step of evaluation. I'm going to machine and print a couple more prototypes, and we should be able to get back over here and verify that. But this is the groundwork that we're putting in to get these to the top tier, highest quality, best performing, that you guys are going to be happy with.